let's go through something called the Organic Chem Guide, Study Guide first. Now, when I left school in, I think, end of 2011, actually I compiled all my teaching on organic chem to come up with the first version of this organic study guide. Okay, so now important thing is you must understand for organic chem, what are something called the common types of reaction. Okay, now if you are not familiar with what is called the common types of reaction, let me just run through with you all very quickly. Okay, now important thing is this. There are a lot of reactions that are mechanism related, which I believe you all know. For example, if you look at FRS, it's for alkanes, correct or not? If you look at electrophilic addition, it's for alkenes. Electrophilic sub is for benzene. Nucleophilic addition is for your carbonyls. And the last one is your nucleophilic substitution, which is basically for your halogenoalkanes as well as your alcohol. Got it? So by learning how to classify the different type of reaction, you can identify the type of reaction. But beside this type of reaction, which are mostly based on certain functional group, we also have other reaction like what? We have things like neutralization, alright? Like what? For example, phenol reacting with sodium hydroxide. Carboxylic acid reacting with a base, also sodium hydroxide. Or amines, which are organic bases, reacting with something like HCl. Do you all follow? Yeah. So this is what we call neutralization. And of course, we also have redox, we have condensation, we have elimination, we have hydrolysis, we have combustion, right? Now, if you are not sure what type of reaction is which, let me just show you all how you can figure out the type of reaction, okay? So let me show you all the easiest way you can figure out the type of reaction is, of course, looking at my organic mind map. Now, if you look at my organic mind map, you can see basically on the arrow, I always have a, like you see this one is R. And if you look at the mind map, it says reduction. If you look at this one, it says HS. Then you can see it's hydrolysis. Do you all follow? Yeah. So identifying the correct type of reaction is important. Clear? So everybody know how to identify the type of reaction. Alright, if you don't know what you do, you check the mind map. Simple or not? Yeah, very simple. So this is the first thing. You must know how to identify the types of reaction. Everybody clear about this? Yeah, I will not go through individually because if I go too deep into the detail, we cannot finish today. Can? Now, today I want it to be a mixture of teaching as well as practicing, okay? So you won't be 100% sit there 2 hours listen to me. I think I will fall asleep also. Okay, come. So let's move on to the next one. Now, this is the one that I will highly encourage you pay a little bit more attention. Now, why? Because these are the different types of questions that come out in your exams. Alright? Now, the first one, which I believe I have been showing you all for quite some time already, is what we call the synthesis type of reaction. Follow? Where you usually have an unknown structure, you have unknown reagent condition, you're supposed to usually come up with the missing reagent condition and the missing structure of the intermediate. Clear, everybody? Now, I will tell you all about the strategy later. I just show you all the different type of question, okay? Alright, second type of question is what we call distinguishing test, which I believe you are familiar, right? So, when you have more than one organic compound, how do you identify using a simple test one of them? Clear? Yeah, so usually what I need to do is to have a simple test that you can use to identify one of them. Now remember, simple test ideally should be just one set of reagent condition. Clear? Yeah, it shouldn't be like, wow, you reflux, then you heat, then you do something else. No. Usually try to keep it to one step. Clear? Yeah, because if it's not one step, it doesn't classify as simple. Everybody clear? Okay? So the second type of question, distinguishing test. Now the third one, this is the one that you need to write a lot of explanation. Understand? Like what? Explaining for rates of hydrolysis. Now, what is rates of hydrolysis? Basically, is the one where you have to what? You have to compare which bond breaks more easily. The first one is the normal halogenoalkane, the aliphatic halogenoalkane. Remember? Yeah. Second one is the halogenoarene. Okay, halogenoarene, the benzene ring joined to a X. Now, I'm drawing on my mouse, so if you find that my drawing is a bit atrocious, do pardon me. Yeah, because I think I don't want to draw on my stylus, using my stylus to draw, it wastes more time actually. Can? Alright, now the last one is what we call an acyl halide. Acyl halide is when you see a C double bond O joined to a halogen. So you want to compare which of these CX bond can break more easily. Understand? Now I'm sure you all have seen this before, correct? Yeah. Now then we also have comparison of acid strength, comparison of base strength. So all the explanation type of question, I like to classify them together. Got it? Alright, so now that we have seen 3 type of question, let's move on to the next one. Shall we? Now I want to tell you all, even though I classify them into different groups, this is by no means 100% exhaustive. Follow what I mean? Yeah, they are the more general kind of question that you will encounter in exam, but they are not everything. Got it? So do not assume that, oh, Mr. Wang, something that is not in your study guide come out for exam. Yeah, this is not meant to be 100% encompass everything under the sun. Can? Alright, now let's move on to the fourth one. Now, fourth one is the one that you always don't like to do, which is the arrow pushing kind of mechanism. You know, you propose the arrow one and then they give you a lot of information. Yeah, so later we are definitely going to try some of this. Okay? Alright, now, everybody familiar? Fourth one, Then fifth one, your favorite. What is this? Elucidation, right? Yeah, to be honest, when I go through the prelim paper these few years, I find that they are really pulling their punches for this elucidation question. They actually reduce the mark weightage of many of these questions, okay? They actually have lesser, how do you call it? Lesser marks for this type of question, all right? Wait, somebody is calling me. Yeah. Never mind lah. Don't want to listen. When I'm teaching, I don't want to listen. Unless you are if it's my student, will text me. Can? Yeah. Let me see whether anyone want to join the meeting, cannot join. I just double check again. Yeah, but I really appreciate y'all coming down because like I say, this is something that I do for y'all to help y'all for your organic and I really hope y'all can benefit from this. Wait Oh, okay, never mind. Yeah, another student tell me cannot come today. It's okay. Now, but like I say, it's all recorded, so you can always review it when you are in need of a revision. Can? Now, the last one, which is the most challenging one, is always the out of syllabus reactions. For example, you look at this. What is the cycloaddition reaction? And some more got Nobel Prize. Wow, sounds scary, right? Now I tell you, a lot of students, they look at question like this. Wow. Surrender. Correct? And usually this is the first time you see in exam. And the last time. Scary, right? Yeah, and you're supposed to read, understand, and do it all within that short 1 or 2 hours. Got it? Alright, so now that you are familiar with the different type of question, let's talk about the strategy. Okay? So you see, I am a very, I would like to put it like a solution and a problem and a solution based kind of approach. So first, you know how to classify them into different groups. Follow? Classify the question into different groups. Then you apply the relevant strategy to solve. Does it make sense? Now, so the synthesis one, you always need to identify the functional group undergoing the reaction. For example, if you identify is a halogenoalkane undergoing reaction, then what will I do? Very simple. Then you go to the halogenoalkane and you see which one of the reaction is it. Does it make sense? Yeah, so you always identify the functional group. After you identify the functional group, if you are not familiar with the reagent condition, it's fine. You can refer to my mind map. Clear or not? Yeah. So the most important thing is try to have my organic mind map with you. Clear? So my suggestion is this: if you are the type of student who always lose what I give you because hard copy always lose or become like folded into A3 or B5, not A3 cannot A3, A4 cannot become A3, B5, B5 I don't know what. So please take a picture of it, can? So that you can carry it with you everywhere you can go, can? Now, I tell you what, instead of me just talking about this, let's get you all to start trying some question right away, can? Now, if you look at my question set, all right, you see my practice question set. Yeah, all this was designed yesterday, fresh off the press. Now, let me tell you where I picked all this question. Okay, to ensure absolute relevance, I actually took it from last year prelim paper. Okay, so all of this question that you see in the question set is actually from last year prelim question. So please don't come and tell me, Mr. Wang, your question not in syllabus. Can? Yeah, because you know some students very funny. They always base what is in the syllabus on what is inside their school notes or tutorial. And when they don't see in their school notes or tutorial, they think that it's outside of syllabus. Yeah. So I need to tell you, your school, they don't give you every single question under the sky. Clear? They can't. Alright? Now, so what I want you all to do now, just take a little bit of time. Look at this question. Now you see we have a W, we have a X, we have a Y, and this is dichromate under distill. So I believe you know what is the structure of Y. Now, what type of alcohol can be oxidized to give a aldehyde? Follow? Yeah, think about what is the structure of Y, and then how do you arrive at the structure of W and X? Think back. Now remember, this is actually having what we call one. How many dB? Can see or not? C4H8 is how many dB? Now, fully saturated is 2N plus 2, right? So 2 times 4 plus 2 is 10. So this one only have 1 dBe. Follow? So this one have 1 dBe. Okay, wait, let me try to type, easier. So this one have what we call 1 dBe. 1 dBe. Ayo. Okay, so since you have 1 dBe, most probably you have a pi bond or a ring. But I believe you know this is most probably a pi bond. Got it? Now, notice this compound got how many carbon? If this compound only have 2 carbon, think about where do you think is the double bond? Understand already? Clear, everybody? Yeah. So can you all just take a little bit of time, look at the organic mind map, come out with the structures of W, X, Y, as well as the reagent condition for step 1 and step 2. Okay, everybody? Yeah. So for those of y'all online, are y'all able to follow? Can follow or not? Give me a thumbs up if you can follow. How about Mervi and Aryan? Can y'all follow? Hello. Oh, thank you. Mervi, can follow? Yoo-hoo. Next time y'all join online, I must insist y'all on your video. Yeah, later y'all watch Netflix. Wow. No, I'm sure y'all won't do that. Y'all J2 already. But please, focus, okay? Yeah, I know it's not so easy to stay engaged when you're online. So really pay attention, okay? Because today I'm really going to make a difference to your learning of organic chem. So we are going to use what we call solution and problem-based approach. classify them into different groups, and then we use the relevant summary to solve. Right, so take a bit of time. I'm going to give you all maybe about 7 minutes. We are not going to take too long. Now, every single question type, I have 3 examples, but I might not be going through all of them. Yeah, for obvious reasons, we don't have enough time. Okay, but I would suggest if you can, go and try to do them. Okay, yeah, I will prepare the solution set for this question for you. Okay, I'll write out the answer myself. I will not refer to the school answer. Yeah, in fact, I don't like to refer to the school answer. All right. But okay, I must be very frank while y'all are doing question. Yeah, there's something that I wanted to do for y'all, but I didn't manage to get it out on time. Remember I told you I want to come up with a list of deductions for the elucidation. Okay, that one is still in the works. So I will pass to you on Saturday or Sunday. Can? Yeah. As you can see, today I come to work, I even have to bring my my little boy. Yeah, school holiday, nobody at home. So yeah, this is my rate determining step. Understand? Yeah, my work speed is depending on him. All right, come. Let me take a look at what you are doing. Come. Now, as I mentioned, if you have a 4-carbon compound, you must chop the chain in such a way that you only have 2 carbon. Make sense? So the double bond must be between carbon what and carbon what? Anyone? Double bond must be between carbon? Harish? Carbon? Double bond between carbon? 2 and 3, correct or not? You see 4 carbon, you chop in the middle 2 each. Make sense? Yeah. But think about what compound will you form. Remember, the precursor before the aldehyde should be what type of alcohol? What kind of alcohol can you oxidize to an aldehyde? Primary alcohol. So you might have a functional group that is related to a primary alcohol. Okay? Remember your CC double bond cleaving. When you chop it, you can either get CO2, carboxylic acid, or ketone. Think about which of these functional groups is more related to primary alcohol. Make sense? Follow what I'm saying? So which one is related to primary alcohol? Carboxylic acid, ketone, or CO2? Which one you can get from that functional group to a primary alcohol? Now, if you don't know, you look at your mind map. Which one can give you a primary alcohol? Now ask yourself, secondary alcohol, is it related to primary alcohol? Sorry, what am I saying? Ketone, is it related to primary alcohol? No lah. Ketone you reduce, you get back. So it's only left CO2 and carboxylic acid. I'm sure y'all know lah. Sorry, as I said, I slept at 3 yesterday. So sometimes what I think and the mouth come out got some what do you call that? Disconnect. Yeah, but I catch myself, don't worry. Okay, quickly, everybody. Now, for those of y'all online, you all solved already? Anyone finish already? Finish? Are y'all done? Yeah, it's been a long while since I have a hybrid lesson. Yeah, remind me of the COVID days. Hello, how? Can do or not? Now I'm going to go through in maybe another 1 minute's time. Okay? Now like I say, the first question is not that difficult, so I don't want to overspend time on this. Okay, can we go through? Come, can go through already? All right, as I mentioned, if you are still struggling a lot for your organic chem, doing this type of synthesis kind of question will really improve your overall ability level, because you train yourself on identifying the type of reaction as well as the reagent and conditions. Okay? Alright, now, I mean, even if you are not done, it's fine, because I am running out of time. Yeah, we can't spend so much time on the first question type. Yeah, because I think today we have to end our lesson sharp at 2. Yeah, they tell me they have another assessment after this. I'm like, I thought it's school holiday. Yeah, but you know, this is a private school, so they also have their students. So I cannot overrun today. Yeah, I mean, anyway, I don't have a habit of overrunning. Okay, my friend, come, let's go through. Now, the first intermediate that I think is the easiest to get is the structure of Y. So as I mentioned, this is a primary alcohol. Correct? So this is just a straight line, okay? Yeah. Follow? Structure of Y. Do you get this? Now, as I mentioned, only a primary alcohol can be oxidized to a aldehyde, right? Yeah, so I'm sure you all know the number of carbon does not change. Since there are 2 carbon, this one should also have 2 carbon, correct? Now, so what functional group is the precursor before this? It's carboxylic acid. Well done. So you draw a double bond O and then a OH. Alamak, sorry. Give me a moment. Yeah, my mouse. Okay, follow? Now, and of course, if this is a 2-carbon carboxylic acid, your respective alkene that you must draw will be something like this. Can? 1, 2, 3. Oh, wait, too many. Yeah, as I mentioned, today my brain a bit like slower. Yeah. Okay, so now if you look at this, you can see that this is a carbon with 1 R group, 1 H. The other one is also a carbon with 1 R group, 1 H. So if you subject it to the hot acidified KMNO4, you will just chop here, and both of this compound is going to give you this. Follow? Make sense? Okay, I don't scroll too high, then you all cannot see. Okay, now let me write in the reagent conditions. Okay, now first step is actually a oxidation. It's the strong oxidation of alkene. Remember? Yeah, so we can call it an oxidation. Now, they never tell you they never ask you to write down type of reaction. But as I mentioned, it's a good practice to write in the type of reaction. Now, if you cannot recall the type of reaction, let me show you all again. Now, you go down here, you can see that this reaction is basically this one, the hot acidified KMNO4. Can see? Yeah, so it's an oxidation. So now, although the summary here write con manganate, now personally I usually just write manganate. So I leave it to you all whether you want to write concentrated or not concentrated. Yeah, so usually I'll just write KMNO4, H2SO4, dilute sulfuric acid, then you heat or reflux. So that's your step 1. Follow? Yeah, I'll just write on top so that you can see more easily. Can everybody? Step 1. Alright, now then let's look at step 2. Step 2 is a reduction. Now, why do you call this a reduction? Because going from carboxylic acid back to primary alcohol is called a reduction. So let's take a look at the mind map. Now, oops. Oh no. Okay, this one is not inside. So, I mean, if you want, you can add in, okay? You add in the arrow. From here to here is a reduction, okay? Just like ketone going back is a reduction. You see, ketone going back to secondary alcohol, we use what? we use sodium borohydride. Now for carboxylic acid going back to primary alcohol, let me write down for you all. Sorry, I forget the arrow is missing. Yeah. So what do we use? Now if you forget because you don't know how to write because it's missing from my mind back, I apologize, okay? You use LiAlH for dry ether RTP. Now, if you are trying to reduce carboxylic acid, you must use the strong reducing agent. I hope you all remember why. Because the change in oxidation number is 4. So when you have a strong reduction, you must use the strong reducing agent. Everybody clear? And there you have it. Alright, so step 3, if you are asked to write what is the type of reaction, you can just say it's a mild oxidation. Everybody clear? Yeah, this is a mild oxidation for step 3. Now, anyone can tell me what type of reaction is step 4? I know they never ask, but I want to ask. Anyone can tell me what type of reaction is step 4? Now, first question I want to ask you is this. Step 4, does it look like an addition or does it look like a substitution? Follow what I'm saying? Step 4, does it look like an addition or a substitution? Now, if you look carefully, this reaction condition is not in the mind map. Got it? And do not be surprised if you see things that are not in the mind map. Why? Because they always give you an application kind of reaction. Got it? So this step 4 is actually an application reaction. Everybody clear? But let's go back to the fundamentals. What do I mean by fundamentals? You ask yourself, carbonyls, what type of reaction do they undergo? You see for yourself, they undergo nucleophilic addition. Understand? And you see, initially you have the pi bond. After the addition, do you have any more pi bond? No. Now, it's not exactly the same because you are not using HCN. Follow? But what are you using? You're using this thing called the HSO3 minus. Now, if you look carefully, the H actually adds across, the H here, add across to the O. Can see? Now, then where is the SO3 minus? The SO3 minus add across to the carbon. You see, this carbon gains the SO3 minus. And the oxygen on top gains the H. Can see? Alright, so what type of reaction is this? This is called a nucleophilic addition. Now I'm just going to write short form, save time. Get it? So far you can see when you do this type of synthesis question, you get used to identifying type of reaction, reagent conditions, as well as structures of the intermediate. So what are the resources you need to use? The main resource you use to solve this type of question is my organic mind map. Simple? Yeah, type 1 done. Okay, so I will suggest if you have time, go and try question 2 and question 3. But of course, today, I don't want to go into the detail, okay? So I will suggest when you're trying to do your revision, do some more of this, okay? Now, I tell you what, to help you all prepare for your prelim and A-level, I'm going to add on to this. That means this file now, you only see 3 questions each. Maybe 2 months later, it will become 10 questions each. Maybe before your A-level, it will become 20 questions each. Happy? Not happy also never mind, it's okay. I think if you buy something and the content keep increasing, you should feel happy, not sad. Can? Imagine you pay one price, watch Disney Plus, you get 12 months free. Happy or not? That's how they ask people to sign up during the IT show, correct or not? Okay, anyway, I didn't sign. Yeah, I was thinking I don't need the Disney Plus. Yeah, don't want to sign. Yeah, I think you all know which telco I'm talking about, right? Yeah, there's one telco, very aggressive marketing during the IT show. Now, second one is the distinguishing test. Now, before we continue with the question, let's go to the strategy first. Ready? Let's look at the strategy. Wait, where is it? Oh, another file. Okay, here. Ayo. Okay. So distinguishing test. What is the strategy that we use? Okay. Now, I cannot overemphasize on this. Please don't go and do a buffet style kind of distinguishing. Ideally, it should be only one step whenever possible. Now, then some student will say, but I cannot see a way that I can do with only one step. Then you better go and revise. Okay. Now, keyword is this. You must have a visible color change. And personally, I don't like these white fumes. I seriously don't like white fumes. Why? Because a lot of this sensitive compound, if they produce white fumes, they can even react with water to produce white fumes. And water is present in our atmosphere because Singapore has a very high humidity level. First strike, second strike you go out already. Shh. Don't disturb my lesson. Mute yourself. Don't care. Yeah, sorry, my boy is in my classroom because nowhere to place him. Yeah. Okay, sharp color change. Identify all the functional group, but usually which one do we use for distinguishing? Do we use the groups that are the same or the groups that are different? Of course, different functional group. Cannot use the same functional group to do distinguishing. Clear, everybody? Yeah. Yeah, and then you should have a unique color change for one of the compound. Cannot both of them give the same observation. Pretty straightforward. Can? Alright, now, so what is the resource that you use for this? Come, I show you. Now, I did this out, I think many years ago, even while I was still in school. Okay, but I updated it yesterday. So this is the latest updated version already. Can? So you can see, let me show you all this resource. Now, if you cannot find where is the resource, never mind. You just look at the screen, okay? Anyway, you don't have to flip to that, but later on, you can take it out to help you all do the distinguishing test. Can? Now, so I want to show you all, when you want to answer distinguishing test question, normally, number one, you need to tell me the reagent and condition, correct? Second thing, you must tell me the observable, distinctive, color, change. Understand? So, third one, the last one is usually you have to write the balance chemical equation. Now, balance chemical equation, sometimes they don't ask for it, but it's always good for you to know it in case they ask. Clear, everybody? Now, so you can see this is a summary that is formed by listing what are the unique, I won't say unique but these are the usual distinguishing tests that we use to identify the functional group. Now, but if you look at alkanes, I'm sure it does not have a, alkanes do not have a distinguishing test. Why? Why alkanes don't have distinguishing test? Now, friend, you tell me what compound don't have CH bond? Huh? I mean, almost all organic functional group got CH bond, right? So what's the point of doing a distinguishing test to find something that has CH bond? Understand what I'm saying? Yeah, it doesn't make sense. Got it? Yeah, so alkanes normally we will not use. Now then some students will say, but I can do FRS. Alamak, I already tell you it's for CH bond, understand? Yeah, almost everything got CH bond. Alright, then let's look at alkenes. Now alkenes, I believe you all know, is all the halogens. Now even though I write Br, I'm sure you all know you can do that for Cl2 and I2 as well. Alright, the respective color change is inside the data booklet. So I'm not going to list out for the others. Clear? Now, the one that I want to mention a bit more is when you have a terminal alkene, you can use your hot acidified KMNO4. Or, if you don't want to use the hot one, you can use the diol. You all know the diol? Diol is the cold alkaline KMNO4. Yeah, I forget to write that down. Yeah, maybe I'll add to it later. But be careful, if you use this hot acidified KMNO4, it can also oxidize side chain of benzene and alcohol aldehydes, and if your functional group can undergo acidic hydrolysis, for example, if you have an ester, ester will undergo acidic hydrolysis when you use dilute sulfuric acid heat. Follow? And if let's say one of the alcohol from the hydrolysis of ester can be oxidized, you will have a color change. Now I give you an example. Now if you draw out the structure of an alcohol, sorry, ester, let me give you a structure of an ester. If you have a CH3C double bond O, okay, let me use the, then O, CH2, CH3. Now, if you have this ester, you use hot acidified KMNO4. This thing can break. On the left side, you will get CH3, C double bond O, OH. Follow? Because this part will be oxidized to the carboxylic acid. Now, oh my, what's going on? Now, on the right side, alright, now come, let's continue. So, you see, when you have this part of the compound, the alcohol that form after hydrolysis, this thing can be oxidized. So that's why I say you have to be careful, because when it looks like it cannot be oxidized, but for some compound when they undergo acidic hydrolysis, the products of hydrolysis can undergo oxidation. Clear? So if you have a 2-carbon primary alcohol, guess what will you form? What will you form for this? What will you form? 2-carbon primary alcohol will just form 2-carbon primary alcohol oxidized to carboxylic acid. So you're just going to get 2 moles of this. Just going to get 2 moles of this. That means you get 2 moles of this. The purple one is also the same. Understand already? So in this case, is KMNO4 suitable to do distinguishing tests between this ester and alkene? Is it suitable? No, because both of them give you the same observation, which is the oxidizing agent will decolorize. Understand? Now, actually, dichromate, I don't like to say it decolorize, because dichromate is orange turns green. We don't call that decolorization. Clear? But KMNO4 is a decolorization. Alright, now anyway, let's just go on quickly, no time. Now, you also have benzene. So for benzene is the nitration. Now, I'm not going to talk about this. You also have your halogenation. The Cl2 will decolorize. Now, take note, Cl2 is pale yellow. Alright, nitrobenzene is also yellow. Can? Yeah, the color. Now, halogenoalkane, you can go and read through yourself. Now, the one that I want to mention a little bit more. Now, many of y'all should not have seen this in your school tests and notes. Now, this ethanolic silver nitrate, I believe y'all never see this equation before, correct or not? Yeah, so this is something that I want to show y'all that I verify with online textbooks. So this is actually the equation for ethanolic. Actually, it's not aqueous, sorry. Cancel away the aqueous, because ethanol cannot be aqueous. Yeah. Ethanol, silver nitrate. This is the equation. Now, what type of reaction is this? This is like a nucleophilic sub. Nucleophilic sub. You will get something called ether. Can? Yeah, but it's similar in the sense that you also look at the color of the PPT. If it's silver chloride, it's white. Silver bromide is pale cream. Now, I think I wrote down as cream here, but it's okay. Pale cream or cream is similar. Iodine is yellow. Silver iodide. Clear? Alright, now then halogenoarene, remember we cannot break the CX bond, so there is no specific test for them. However, if you cannot break the CX bond, but you can make use of the benzene ring, right? Follow? Because this one Cl bonded to benzene, the Cl does not react, but if one of them have benzene ring, the other one don't have, then you can use the distinguishing test for benzene. That means you can do a nitration, and then you get the yellow nitrobenzene. Follow what I'm saying? Yeah. Alright, now let's continue very quickly. Now, for alcohols, you can separate the primary, secondary alcohol that can be oxidized from those that cannot be oxidized. Now, the one that cannot be oxidized is your tertiary alcohol, right? So what are the oxidizing agent that we use? You either use your dichromate or your manganate. Clear? Yeah, very standard. So I don't want to go through too slowly. Now, and you see, Mr. Wang do this for you. You see, I compile a nice document that have all the balance equations. So for those of you who are fans of memorizing stoichiometry for the distinguishing test, this will be good for you. You see, all the 7 numbers are here. You see, you can memorize. Wow, so good, you know. Everything compiled into one. Get it? Yeah, so like I say, all this I did it while I was still in teaching, but I just refined it. Yeah. Okay, so you see I give you all a lot of useful resource, so make sure you all make use of it, can? Yeah. So I don't want to go through this slowly one by one, but you basically understand what I do for this document. Clear? I compile all the distinguishing tests for the important ones into one document. Happy? Yeah, you see? Wow, until carboxylic acid and primary amide. But of course, some of the subscript and all that are not done out properly. I will go and fine tune it a little bit. Now, I know some of your OCD one, I cannot like that. I can, yeah, like I say, I do until 3 a.m. Some of them I refine. I mean, this is actually, I would say 90% done out. I just fine tune a little bit yesterday. Okay, any question? Clear on this? If clear, we go to do simple question now. Let's go to the distinguishing test. Now, the first one is how you differentiate between pentane 2-none versus the N-propyl ethane amide. So think about which functional group do you want to use as distinguishing. Now, I hope you all understand this is an amide. But is this a primary amide? Okay, no. In case you are wondering what type of amide. Now, for amides, because you haven't learned nitrogen compound under me, I will just explain. If you look at this nitrogen, it's bonded to 2 R group. Can see 1 R group here, 1 R group here? So this is not called a primary amide. This is actually called a secondary amide. It's called a secondary amide. Now, not second degree, secondary amide. Yeah, some students tell me, second degree amide. No, secondary amide. So do you have a distinguishing test for secondary amide? Have or don't have? Don't have. So it's very obvious which one you should use already. Understand? So you can see, if you have my mind map, you have my summary, doing question is like a walk in the park. Agree? Yeah, so please get all this information into your head. Can? Try. Come up with a simple test to differentiate between these two. Wow. Life is never complete, or lesson is never complete until a technical difficulty arises, right? Yeah, we call it Murphy's Law. Yeah. You see, it's always good that I bring extra things. Yeah, who will know that the thing just doesn't work suddenly, right? Yeah, thank God that I'm always prepared. Yeah, I bring my barang-barang, almost like Doraemon. Wow. Okay, quickly, my friends. Are y'all learning from this? Yes? Understand what I'm teaching y'all to do? Now, I don't expect you to absorb everything 100%. What I intend to do for today's lesson is to show you a path on how you can prepare. Get it? Yeah, even if you don't get the answer right away, it's fine. Clear? Yeah, the key thing is how you tackle this type of question and what resource you use for tackling it. Happy? So that's why I say today if you come for the lesson, it's like, wow, suddenly you get a light shining on the different type of question. And that's the purpose of my lesson today. Alright, I want to clarify a lot of doubts on how to tackle different type of question. And seriously, I don't think many of your teachers would have done a similar thing for you. Correct or not? Did they group question by question type? Have or not? No, right? They just whack you with the tutorial you do. Okay. Alright, how are the online students doing? Are y'all following? Hello? Huh? Anyone sleeping already? Huh? Are y'all there? Anyone got any problem? Give me a thumbs up. Okay, good. Thank you. Okay, now let's go through, shall we? Now this is a simple question, so let's don't waste time. So if you take a look at the summary again, alright, so like I say, if you have a good summary, your battle is half won. Now, so what will we use for this distinguishing test? We will obviously focus on the ketone. Now, which equation do you prefer to write? Do you prefer to write the 2,4-DNPH or you prefer to write the triidol? Now, in the first place, will triidol work for this compound? Will triidol work for this compound? Yes? Of course, because there's a CH3 here, correct? So in this case, you can either use your 2,4-DNPH or your triidol. Can? Now, personally, I prefer to use 2,4-DNPH. Why? Because I believe I've told you how to remember the structure of 2,4-DNPH, so I'm not going to repeat. The stoichiometry is so much easier to get. Everything is just one. Correct? But if you want to remember triidol, then you have to remember the method I teach you on how to remember the stoichiometry. Correct? Yeah, so personally, if I'm not asked to write the balance equation, if you don't want the balance equation, either one will work. But with balance equation, which one you prefer to write more? 2,4-DNPH. Personally, it's easier. Lesser chance of you making mistake. Make sense? So for this one, do they want you to write the balance equation? Yes or no? Did they say? Wow, this one is like strike total. No need to write balance equation. So either one will work. Just give me the reagent condition and the observation. Clear, everybody? So basically, if you use 2,4-DNPH, you will get an orange PPT for this. This one will be no orange PPT. If you use triidomethane, you will get a pale yellow PPT for your ketone and no pale yellow PPT for your amide. Everybody clear? Simple, right? Got it? Okay lah, done. Happy so far? Now, let me get you all to try this one. Now, I tell you all something. For this compound, let's identify the functional group together, shall we? Now notice the synthesis one, I didn't spend a lot of time going through. Why? Because the synthesis one, I think is quite easy for you all to do. Can? So I believe if you tackle it on your own, you should encounter lesser problems. Okay, for the ones that have more problems, we'll try a little bit more. Now I want you all to look at this. What type of functional group is this? Is it considered as an aliphatic alcohol or is a aromatic alcohol? Is this a phenol? Is it a phenol? Yes or no? No, please. The OH is not bonded directly to benzene. So this is a aliphatic. What type of alcohol? Primary, secondary, or tertiary? Primary. So this is considered as a aliphatic primary alcohol. So, question. Do you think we can use this as distinguishing? Yes or no? Is this the unique or the same functional group? Same lah. So if both of them have, can you use this for distinguishing? Of course not. Clear? Now, second one is what? Second one, if you look carefully, this is what functional group? They are both. I like to call this the human pheromone. Then you'll say, what is pheromone? You all know the chemical that animals secrete to attract species of the opposite gender. Human beings like to spray this to attract species of the opposite gender. You say, what are you talking about? Perfume, understand? Perfume. Esther. Correct or not? Human being must man-made one, artificial, not real. Because if the normal body produce one, that one is bau, that one not pheromone. Okay, sorry. Just pardon me, sometimes I just like to talk nonsense, but anyway, come back to here. Now, listen carefully. For Esther, do you realize that you don't see it in my distinguishing test? You don't see a distinguishing test for Esther, correct? So today, write this down. For Esther, we usually do hydrolysis. But listen carefully. You want to do hydrolysis and you differentiate the compound based on the products of hydrolysis. Do you understand what I'm saying? For example, just now I spoke about the the KMNO4 with the ester, correct? The one of the ester, the alcohol can be oxidized, right, after hydrolysis. So you will see a color change. So I want you all to think, can I use the same reaction for these two ester? Can I use the same reaction for these two ester? Can or cannot? That means I use my hot acidified KMNO4. Will it work? Or it wouldn't work? Tell me. What should I use? Now I give you a choice to make it easier for you. If I use dichromate, what will be my products of acidic hydrolysis? If I use manganate, what will be my products of acidic hydrolysis? Follow what I'm saying? Think about it. If you use dichromate versus manganate, is there a difference? Now, my suggestion is notice the side chain of benzene. Be very careful. Clear? This question, they purposely put this carbon here to make you all think. Because you look at this carbon, it's bonded directly to benzene. Does it have the H? Yes. So I hope you all remember, when the carbon bonded to benzene got H, what can happen? Clear? So think about which oxidizing agent you must use. Clear, everybody? Okay, try first. If I'm you, I will think about what kind of alcohol I form after I do acidic hydrolysis. Okay, what kind of alcohol do I form upon acidic hydrolysis? Alright, so another 1 minute before I go through this. Now the rest of the time, I want to tackle the harder question, but today most probably we are not doing the deductive. Maybe application we can go through. Can? Yeah, we see how. Deductive I cannot go through today because I haven't come up with a summary for you. Can? Yeah, that one, you all know, even though the summary looks very thin, 3 pages of summary. You all know how many hours it takes for me to write one? Don't know. Can tell you, minimum 3-4 hours for 2 pages. Can? Yeah. So please, don't happy share with other people, can or not? Yeah. Respect my intellectual property. Okay? Yeah, it took me many hours just to write one summary. I suspect just now that adapter overheat. Yeah, looks like overheat like that. You see all the thing came out. Yeah, I changed to my adapter, now it's working. Funny. Wow. Luckily I brought. Headache. Okay, question. So what do I use to oxidize? Do I use dichromate or do I use manganate? Anyone? Manganate or dichromate? Now, do I want to oxidize the side chain of benzene? Of course not, because both of them contain the side chain, right? So what should I use then? Yes, I should use dichromate. So I want you all to think, if I use dichromate, after you cleave off the ester bond, which alcohol can be oxidized? And what is the observation? Clear? Okay, going through very soon. Alright, so for those of y'all online, are y'all following? Clear? Okay, yeah, like I say, it's been a while since I have a hybrid lesson. So I always want to check whether you are following. Yeah, thank you. Okay, how? Finish already? Come up with your observation and deduction. As in reagent condition and observation. Yeah, I think I must go back and put my watermark on all these documents. Yeah, later end up in some other tuition center notes. Seriously, you know, some people they just take other people's notes. Yeah. Okay, now come, let's go through, shall we? Hello? Come, let's go through. So reagent condition, what do we use? We use our acidified dichromate. Now I say again, why you cannot use manganate? Reason is because your side chain here, both of them have the H. So if you use KMNO4, you will just cleave off both of this and you're gonna get what? Benzoic acid. Understand? Anyway, you are not going to cleave off, but you are just going to oxidize both of these to COH. Oh no! My goodness, cannot. Okay, I will explain to you why it doesn't work. Okay, later. Okay, now by right, okay, hang on. Let me just ignore this for now. If we don't have this blue color group, using dichromate will work. Okay, if we don't have this blue color group, using dichromate will work. Why? Now, let me draw out the ester product first. Okay, listen. So, if you cleave this bond, correct? So, this one you get back what? Phenol. Now, can phenol be oxidized? Can phenol be oxidized? Now, just ask yourself, this carbon, does it have a H? Does it have a H? No. Why? Because double bond. You see, this carbon already have 4 bonds. Phenol cannot be oxidized. Clear? Now you draw your pi bond, pi bond like that, correct? This carbon already have 4 bonds. Now look at this. For this compound, you cleave off. So this is actually ethanol. Can see? This is ethanol. So question, can ethanol be oxidized? Of course. Ethanol will be oxidized to form what? Ethanoic acid. Clear? Now, if you don't have these blue color groups here, you can use dichromate to distinguish. Follow? Why? Because after you use dichromate to do acidic hydrolysis, this one cannot be oxidized, but this one can. Follow? But what is the issue? Do you see that we have a primary alcohol on top? So will these two react with dichromate? Can primary alcohol be oxidized by dichromate? Of course. So I tell you, the answer will not work for this. So evil, right? Wow, like that how? Tided. Okay, never mind. This is the highest level of Kung Fu already. Okay, now I tell you. The proper reagent condition that will work. Yeah, I wonder how many of y'all will be coming out with this if I don't go through with y'all. Now, you use sodium hydroxide, I2 equals heat. Now, anyone can tell me what type of reagent condition is this? Triiodomethane. Now, listen carefully. I'm going to draw out the product of triiodomethane. Now, oh wait, triiodomethane also don't work for this. Why? Because this is ethanol. Ethanol can also give positive triido, so this one also wouldn't work. Wow, headaches, yeah. Now, if this is not a ketone in CH3, this is ethanol. Remember, ethanol can give you triido? Okay, wait, let me see. Wow, seldom I stun for a while. Wow, I love this question, man. Yeah, what should we use? Wow, my brain actually hurts. Yeah, but wait. In that case, I think we got no choice. We might need to use a hybrid reagent. Okay, then you all say, what is hybrid reagent? Now, this one you never see before one. Okay? Now, if you don't know why triido don't work, don't worry, I explain one more time. Triido, the reason why it doesn't work is this. Triido, if you cleave, wait, triido works? Ayya, damn. I'm sorry. Okay, I explain why this one work and I explain why triido work also, can? I'm sorry, pardon my brain, today a bit laggy, yeah. Okay, I explain first this one. Now, when you use dilute sulfuric acid, what happens? You cleave off this bond, you cleave off this bond, right? Now, and when you have Br2 aqueous, what will you do? Electrophilic sub. Can see? This one can react, but can this one react? Cannot. Because do they have a highly activating group? No. How do you know whether you have a highly activating group? Remember I mentioned to you all the carbon bonded to benzene ring must have what? Lone pair. So this is an alternative reagent you can use. But this one a bit like cheating because you combine the acidic hydrolysis and Br2 aqueous together. Can? Okay. So if you use this reagent, you will see the Br2 decolorizing for this. Because you can sub where? You can sub here and you can sub here. Follow? You can sub at these two positions. Got it? Anyone not clear about the Br2 aqueous? Follow so far? But you cannot just have Br2 aqueous. You need to have acidic hydrolysis because if you don't cleave, oh wait, what you want to ask? Come ask You can unmute yourself and talk. Wait, cannot hear you, louder. Okay, I explain one more time. You see, first step is actually dilute sulfuric acid. Now, what will happen if you have dilute sulfuric acid? You will basically cleave off this ester bond. You will get back, listen carefully, this side you get back a carboxylate. This side you get back a phenol. Follow? And the Br2 aqueous is actually reacting with the phenol. Understand already? Follow? Different. You must tell me leh. You nod your head, I cannot see, okay? You type in the chat or what if you follow. Can? Otherwise I cannot see. Can Okay. Yeah, thank you. Now, listen carefully. Now I explain for trido. Can? Trido is the one that headache. So this one, like I say, is a bit like cheating. You combine two reagents into one. But sometimes no choice. Yeah, desperation calls for inspiration. Can? Yeah. Now let me talk about the trido. Listen. Wow. Triido is sodium hydroxide aqueous I2, heat or warm. Now, number one, let's talk about what will you form when you let it undergo triido. Follow so far? Now, I erase everything first, as in this one. Okay, this one. Okay, come. So if I use triido, now first thing is this is alkaline hydrolysis because you have sodium hydroxide equals heat. Follow? Now then what will you do? You will cleave off this bond. You will cleave off this bond. Follow? Cleave the ester bond. Now, so for alkaline hydrolysis, you will not get back the phenol. You get back the phenoxide. Follow? Why do you get back phenoxide? Because phenol is acidic, you will react with sodium hydroxide. You will get back O minus Na plus. Follow? Now then what about this side? This side what will you get back? Instead of getting back carboxylic acid, you get back carboxylate. So you get back the O minus Na plus. Is it making sense? Follow? Now if you haven't learned your ester, I believe you all recall in your secondary school. You all learn about ester. Now if you cleave an ester bond, normally you get back an alcohol and a carboxylic acid. Agree? But carboxylic acid is acidic, right? It can react with sodium hydroxide. That's why you get a carboxylate. Phenol is also acidic. That's why instead of getting phenol, you get back phenoxide. Make sense? Now, question. Can any of this compound undergo triidomethane? No. This is not a ketone. This is a carboxylate. Yeah, just now my brain, like brain freeze. I couldn't see. I thought it's a ketone. I blur already. Can see both, cannot react? Okay, then we talk about the right side. Ready? Okay, see, this one is the carboxylate. The O minus Na plus. Follow? Now then what about this side? The other right side, let me draw using another color. This, you're going to get an ethanol. Now remember, alcohols are neutral. Follow? So can ethanol give you a positive triidomethane? Yes. So if you ask me which one is the preferred answer, this one is better. This one like never play cheat. This one play cheat. This one like combine two reagents into one. Follow? But who cares I mean, in moment of desperation, you can't think of triido, then you come up with something If it works, you get some marks. Don't work, forget it Lose 1 or 2 marks is fine. Okay? So what is the key thing that I'm trying to show you all from this example? For ester, is it really the distinguishing test of ester? Do you use the distinguishing test of ester to differentiate ester? No, we are using the products of hydrolysis, which is usually the alcohol or the carboxylate that's formed. Understand what I'm saying? But notice carboxylate, we don't really have a distinguishing test. So normally we use the alcohol to do distinguishing. So now you understand why for ester I don't write in the distinguishing test. Yeah, because normally we do an acidic hydrolysis or basic hydrolysis followed by triidol or dichromate. Follow what I'm saying? Okay, very good. Now, I don't want to go on to the last distinguishing. You all can go and try yourself. Follow so far? Alright, let's go on to the next question type. Okay, so far so good, huh? Yeah, can still take some more? Yeah. Alright, now explanation question. I'm not going to spend too much time talking about this. We are not going to practice this question today. Why? Because to do this, you have to come up with a summary of the marking point. Like for example, carboxylic acid, you need to explain in terms of what? Still remember? Stability of the anion. Then you need to talk about the electron withdrawing group, the resonance, and then the POE more to the right hand side, so on and so forth. Correct? So you can see I gave you all the so-called marking points for the acid strength comparison. So for the acid strength comparison, these are the marking points. Follow? So what you need to do for yourself is to come up with the marking points for the rates of hydrolysis, the CCl bond one, which one easier to break, as well as the base strength. Clear or not? Now, can I leave it to you all to do, or you want me to do for you? Want me to do want me to do wait I give you all on Saturday Yeah. Well, I do a lot of OT this week so you all must work hard also, okay? Yeah. So please, after this holiday, if you all have a WA, I hope you all really do better for your organic. Can? Yeah, I give you all so much of my. Yesterday I was just joking with my wife. The Kung Fu master, every time I must go into seclusion, right? Hide in the cave, then practice the Kung Fu. And then suddenly come up with a new Kung Fu manual. Okay? So yesterday, that's what I'm actually doing at the middle of the night. Yeah, and why must I always do it in the middle of the night? Because everybody is sleeping beside myself. Yeah, that's when I have the peace and the time to write. Okay? Okay, now, the more important one that I want to go through today is the mechanism. Okay? Now, for mechanism, like I say, you need to know what are the 5 standard mechanisms, which I believe you all know. Can? Yeah, the 5 standard mechanism is not that difficult, but I'm sure you know which are the harder ones. It's the one where they give you a lot of information, you propose the arrow pushing, correct or not? So, these are some of the pointers that you can take note. So, always read the information given in the question carefully. Try to draw out the full structural formula, okay? And notice which type of bonds are formed and broken. And remember, you always show the arrow pushing to show how you form the bond and how the bond break. Can? Yeah, and electron must always come from who? The electron rich or electron poor? Yeah, electron must always come from the electron rich to the electron poor. I'm sure you all know that. Yeah? Okay, and I mean the standard one are the partial charges, the half-headed arrow, full-headed arrow. Yeah, slow, I think usually you don't really label slow stat unless they give you the info. Clear? Yeah, so substitution usually occurs when a compound is fully saturated. But nucleophile addition will usually happen for a compound that is non-saturated. Can? Yeah, and I hope you all remember how to see something that is electron rich. Electron rich, they usually have lone pairs or negative charge or pi bonds. Pi electron, right? Now, electron poor, usually the carbon is bonded to a more electronegative atom. Get it? Yeah, all the standard stuff that we have been talking about now. But enough talk, let us try question right away, shall we? Yeah. So like I say, try to give your notes a little bit more life. Yeah, use a color highlighter. Yeah, you see, after I draw with a few colors, you see, you look at the notes, it's not so dead already. You know. Yeah, come, let's try some question on the arrow pushing. Now, I say again, these are questions from last year prelim. Your senior just took it. Yeah, they are the last batch of the 90 rank point. So you are the first batch of the 70 rank points. Alright, the acid-base comparison I'm not going to go through, okay? So you all can go and look through. So I have one on the acid-base strength comparison, one on the rates of hydrolysis of the CX bond, and of course one on the base strength comparison. Can? Yeah, so one for each of the explanation question. Now we go to the electron pushing. Alright, my friend, let's look at this together, shall we? Now this is from last year prelim, so you can see this is another reaction that looks kind of complicated. They say that this compound undergo the decarboxylation process with the generation of free radicals. Now, keyword. When you see radicals form, should you use the half-headed arrow or full-headed arrow? Okay, listen carefully. When you see radicals, you must always use the half-headed arrow because this is movement of one electron. Follow? Half-headed arrow, not full. Clear? Second thing, okay, mechanism for step 1 you don't need, okay. You just need to draw step 2. How you go from here to here, and they tell you, wow, 5 half arrow. Hey, they are so nice that they even tell you half arrow. Have fun. Yeah, I'll go through this very shortly. Can? Yeah, go and draw your arrow pushing. Okay, I think, sorry, if you are getting a bit confused, which actually I am, is this plus this is the reactant A, reactant B, follow? Then you get the products. So the products is this, wait, change color. Okay, the products are this. Get it? Okay, so you have 5 half-headed arrow. Go and draw. Now, like I say, if you are not very clear which atom is which, it will be good for you to expand out all the bonds so that you can see more clearly. For example, if you look at this tail, friend, you tell me this tail from where? This tail from where? The left compound or the right one? This tail. From here or here? Hello? This one give the tail or this one give the tail? This one. Can see or not? This one or this one give this tail? Hello? Hey friend, you count right? This one got how many carbon? 3 lah. Hey friend, this one got how many? How can 2 carbon become 3 carbon? Hello? Cannot lah. Must be here lah. So simple. That's why I say, sometimes when y'all cannot do question, I suspect is that y'all really don't have enough sleep like me. Yeah. But if you don't have enough sleep like me, you cannot perform like me one. Why? Because I half asleep, I also can do this. But for y'all, I don't think you can. Yeah. Why? Why I can do, friend? I do for so many years. Maybe even if I have half a breath, I also can do. Quickly, because we are going to round up very soon already. Yeah. But I believe you all know what I'm trying to teach you all today. Yeah. After you finish with step 2, if you are faster, you can go on to the step 4. Step 4 is more fun. This one is full-headed arrow already. Yeah. You see, I love this question because that's on radical and the normal full-headed arrow. And it didn't really take me that long to compile this question set. I think I spent maybe 1-2 hours. Yeah. But even when I spend 1-2 hours, I tell you, I look through at least 7 to 10 different prelim paper to come out with this simple question set. Okay? Yeah. As I mentioned, I'm going to add on to this, okay? So I will have more questions added to this, and I will come with a solution. Alright, so this will accompany you for your preparation for A level. Can? Yeah, so if you are very scared of organic, yeah, just go and do this. Alright, let me see your arrow pushing. Come. Okay, finish your first one already? Can do? No? Okay, you see, if you take a look at this, the radical is actually on the third carbon. So where is the radical going to go to? 1, 2, should be this one. So if you go here, which bond should break? Okay, if for those of y'all who cannot see what I'm talking about, I show y'all here. Yeah, my camera go crazy again. Hello, here. Follow me. Follow. Okay, come, look here. Let me label the carbon for y'all. You see, if I say this is red color carbon, this red color carbon will be this one. Follow? So if this carbon were to have a radical, the bond that break should be this. Agree? You see, if this carbon were to have the radical, the bond that break should be this. Right? Now, then you ask yourself, what about the others? Now, let me ask you, which one? Okay, let's change the labeling of the carbon. If I draw, okay, look up, yeah, look up. I'm trying to teach you how to analyze this, which is not that easy actually. Now, if I draw this as a green color carbon, hello? Now, can you tell me, the green color carbon, is it in my CO2 or my ethanoic acid? This green color carbon, is it here or here? Now you ask yourself, when this bond get cleaved off, this green color carbon is only how many carbon? This fragment? Only one carbon. So it should be the CO2 or the ethanoic acid? CO2. That's why I say you must learn to analyze the bond break and the bond form. Follow what I mean? And when you learn how to analyze the bond break and bond form, it will become so simple. Clear? And you know why you can't see? Because your one all same color, you can't see, right? I told you already, you need a few different color one, you don't believe. Yeah, no color, no life. Follow? So now, let me ask you all now. If you want to go to form CO2, which bond must break? Which bond must break? The OH bond must break, of course, right? So listen carefully. When the OH bond break, how does it break? Okay, hang on. Do you notice you don't get a C radical, you get CO2. So listen carefully, this arrow draw wrong already. This red color arrow shouldn't go to the green color carbon. It should go to where? It should go to the CO pi bond. As in the, okay, listen, I draw. This bond break, one go back to the C, this one go back to the CO. Follow? Then this one, the green one, look here. This one will go here. One electron here, one electron, I have my CO2. Happy? Now you see. Now, the other one, you need to get back your ethanoic acid, right? So this one we can label the purple one already. Okay, so we draw the purple. So you can see this is really testing you on your logic. So you see if the CH3, this CH3 is of course this CH3. Then this one go from a COO radical to a COH, right? That means this like this. Understand? Now why I draw in the middle? Because you form a OH bond. Understand or not? So you count how many arrow? 1, 2, 3, 4, 5. Ta-da! All these for 10 marks. How much? Wow! Inflation is real. All the 5 arrow for 1 mark. I think it's kind of evil. 5 arrows for 1 mark. Wow. Which school? Won't tell you. Very evil, right? This is a classic A differentiator question. Get a better idea on how I do? So do you all know why you cannot draw the arrow pushing? Because you cannot identify which carbon is on the left, which carbon is on the right. Clear or not? And when you identify already, what should you do? Try to draw some labeling. Use a different color, use some color pencil, or you draw what, circle, square moon, or whatever. Can just have a way of differentiating it. Does it make sense? Follow so far? Yeah. Anything you all want to ask or clarify? Is it making sense? Make sense? Okay, Now, anyway, I think now we can try one more on the arrow pushing. So I let you all try this one. Come. Now this one quite obvious. This is purple. This is purple. Right? Now then you draw the other one. The other one is an alkene. So you think about how you get an alkene. Clear? Now I give you a hint. For this one, you need to draw the lone pair. You need to draw the lone pair. Okay? Think about where the electron pushing starts. Now, I always find that students are weaker for radical mechanism. You all know why? Because the only radical mechanism you know is FRS. And FRS, you never understood. You just memorize one. Suddenly give you this type of application radical mechanism. Cannot do one. Correct or not? You'll be surprised. You go and check last year prelim. How many schools they actually test on radical mechanism? Many. Okay? But let me just say it this way. Now it's only March. If you take another 3 months to practice question like this, do you believe you can become better? Can or not? Now, if you don't think 3 months you can, half a year, can or not? Can you become better? Of course lah. So please, walking in the correct direction, even if you are slow, you'll still get there. Provided you are walking in the correct direction. Alright? So that's the purpose of this lesson. I want to show you how you revise. You know, I've been telling you 80% of your time should be spent practicing. Follow? And when I mean practicing, practicing question like this. Okay, quickly, we are going to go through pretty soon. Now, if you finish with this question already, I don't think I will go on to the last arrow pushing, but again, you can go and try this on your own, alright, because we still have another 2 more questions. You see, this is just 1 question, okay? We have another 2 more questions on the arrow pushing. Yeah, we have 3 elucidation questions and also an application question. So I think the last 10 to 15 minutes, I would want to try at least one of this application question. Can? Yeah, I want to show you how we tackle a more challenging application question. Yeah, you see, so fun. Wow, fluorescent molecule, cycloaddition. Wow, so fun. Alright, try for a while first. I'm going to take a quick toilet break and I come back. I hope we can go through this. Can? Yeah, I'm just going to mute myself. Yeah, let me take out my mic first. I mute myself. Yeah, later if y'all cannot hear me, please remind me to unmute myself. Yeah, I will remind myself also. Okay, let me mute myself first. I take out my mic. Okay, great. I will be back shortly. Can do it now. Tired already. Out of juice. Okay, how? Can Can we go through already? Can go through? Hello? Can go through? Okay, let me unmute myself first. Right, anyway, our lesson is finishing soon. 10 more minutes only. Can? Yeah. Relax. Okay. Now, so I hope you all can see, we go from a carboxylate to a carboxylic acid. Now, important thing is this. There's a reason why they draw out this H. Alright? So, the first step of this reaction should be the C. Okay, this is a lone pair. Sorry, I'm using my mouse, can't draw very properly. You go and attack this H. Now, take note, it's a full-headed arrow. Now, ask yourself, this electron must go somewhere, correct? Now, they say alkene already. Guess go where? Yeah, you just go down to form the pi bond. Finish. Wow, the full-headed arrow is like so much easier to do. And then 2 arrow, 2 marks. Just now the half-headed arrow, 5 of them, 1 mark. Alamak, why like that? Correct. But I think they are quite kind. Do you notice the easier question is worth more marks? The harder question only worth 1 mark? Yeah, so I mean you won't fail that easily but alright, anything you all want to ask regarding this? Is it making sense? Can? Alright, now I think we will not try any more question because I don't have time to let you all try already. But what I want to do now is to run through the rest of the strategies that I told you all earlier. So we still have 2 other type of question. So one of them is of course the deductive question. Now deductive question, something that I always emphasize is to always use the double bond equivalent method to find the DBE. Can? Now, and the question I always get from students when exams are near, Mr. Wang, how to count the DBE? Okay, so in order to preempt this question, I wrote out a summary. So let me show you which summary. Come. So my friend, you know all these summary, each one of them minimum 2 hours to write out. So you go and see how many summaries I gave you all today. Yeah. So easily like 10 hours worth of work. Seriously. Okay, you go to the one that say essential organic concepts. This one. Yeah, forget to add in my watermark and all that. Yeah, must go and add in. Okay, now, if you look at this essential summary, alright, let's just run through this quickly. You can see that I have a few different concepts that is important, and I run through with you how you find. Now, the first one is actually what we call determining hybridization state. So I won't go through in detail. You can go and look through yourself. I identify the different atoms and how I find the hybridization state based on the number of electron pairs. Now, the only important thing I want to emphasize is when you have lone pairs of electrons, they are delocalized. They are not considered for hybridization. Got it? Yeah, so do take note of that. If you have lone pair of electron that's involved in delocalization, we don't count them for hybridization. Clear? Okay, now not only that, this section is important, but to be honest, I think many of y'all will not appreciate this now. Okay? Because these are the different types of scenarios that you will have delocalization. When you have a plus charge beside minimum 2 atoms, they are sp2. So you can see this is the sp2, this is the plus. So minimum must have at least 2 atoms beside the sp2. Aiyo, why cannot click? Come on, let me click. Aiya. Yeah, this thing just doesn't allow me to click it. What's going on? Let's see. Okay. Cannot use mouse, must use my finger. Can you see this is a plus beside 2sp2, a plus beside 6? Yeah, so when you have a plus beside sp2, minimum 2, you can have resonance. Can? Now, beside plus, what else can you have? Very simple, you can also have minus beside sp2. Can see these are the sp2. Same problem again. Crazy. Okay, here sp2, here sp2, here sp2. So notice it's always a charged species beside sp2. Minimum must have 2. Got it? Now the last scenario, no charge but lone pair beside sp2. You can also have resonance. Now I believe this is one of the most comprehensive summary you see on resonance already, because in many schools they don't talk about resonance in great detail. In fact, I can tell you, I referred to a university textbook to write this. Yeah. Okay? So I refer to a university textbook to make it clearer. Okay? So these are the 3 scenarios, whether a positive charge, a negative charge, or lone pair beside sp2. So minimum you must have how many atoms involved? 3 or more. Can see? Minimum must have at least 3 atoms. Then you can consider as resonance. Got it? Now, anyway, effects of delocalization, I don't want to talk about it. You can read through yourself. Now, finding of oxidation number using the win-lose draw method. You see, I also write out for you all. Alright, we went through this when we are talking about hydroxy compound. Remember? Yeah, the win-lose draw method. Alright, now this is the one that I want to talk about. You know the double bond equivalent method? Can you see? This is the write-up on the double bond equivalent method. Not going to go through this, you can read through yourself. So whenever you forget how to count DBE, okay, you don't text Mr. Wang in the middle of the night. Okay, what should you do? You take out the summary. Understand or not? If you read already, you don't understand, you can text me. If I'm awake, I will go through with you. Yeah, but please not 3 a.m. at night. Yeah. Okay, so listen up. After you know how to count the DBE for the elucidation, what should we do? Well, of course, yeah, I know you're tired already. I'm also tired. Yeah, but I tell you what, we will not go through the last 2 types because today we don't have enough time. But I believe you all have learned quite a fair bit today. What remains to be done is putting into practice what we have covered today. So as I said, I will continue to add on to the organic question set. And if you do already, you got problem, you just ask me. I'm going to compile the solution set also. Now, so you go and read through. I mean, it's not a lot. I only left 2 paragraphs. Go and read yourself. The last one is really no choice. You have to practice more prelim paper. Yeah, and don't spend too much time practicing if your basic is still weak, because these are meant for students who are higher performing. Now, you might think that you're not higher performing, but that is only now. Eventually, I hope you become better. What? I can hear your video. What? Alright, so I think I will stop here for today. So thank you for coming, and I hope you all learned something from today's workshop. Alright? So this is, like I say, something extra that I want to teach you. But is it important? Very important, Okay? Alright, take care.